All right, here is number 5. Let's take a look. Now this lesson is on simplifying rational expressions. And some of them look like they're pretty straightforward, but there are multiple ways to do them which are helpful when you do some of the other ones later. So for the first one here, if it says, excluded values, well, I can look at this and I can say, so x squared minus 1, well, x can't be 1. It also can't be negative 1. Let's look at another way to do that. Because x squared minus 1, if I factor it, would be x plus 1 and x minus 1. And of course, 5x plus 1 is on top. Now that you've factored that, because let's see, x times x is x squared, 1x, negative 1x, and then you have negative 1. That shows you right there that x has to be negative 1, positive 1. Can't be those. Set it to 0. This one over here gets a little different. You can even factor the top on this, because you should have k minus 2, k plus 2. And I'm doing that because that will come up later. K squared minus 4, yep, and the other k's disappear. Now on the bottom, let's see, I think it must be k plus 8, k minus 3. If I factor that correctly, k minus 2, k plus 2, squeeze that in there, because I know that I needed something to be 24 and it needs to be positive. The bigger one needs to be positive. The reason I did this is to see, is there anything I can cancel, and I can't. So the excluded value here would be negative 8 and 3. Now for these examples, and by the way, these are on page 694. This one over here is number 19, and this one is 23. So the thing here is, you could say, well, n can't be 0 and p can't be 0, I guess, but we can also factor things out of here and get rid of things. So like 2 and this, that becomes 16 up here, and n squared, n to the 4th, that one goes away, and this becomes n squared. Subtracting exponents, 2 minus 4 can be n to this 2 on the bottom. And then these actually just cancel out. So what you have is you have 16 over n squared. That is the simplified expression, by the way. But then you have to also say, well, if that's on the bottom, n equals 0, or you could say n cannot equal 0. And then, as we already said, since it started out with a p on the bottom, it would be p cannot equal 0 either. So there are your excluded values on that one. Now on this, as soon as I see this one over here, I'm going to factor a out of the top, and I'm going to have a plus 3. Now on the bottom, it looks like it must be a quadratic function, so I'm going to, or a quadratic equation, so I'm going to factor that. Let's see. I'm thinking 6 and 3. A minus 6, a plus 3. And I had to make the 6, the negative, the bigger number, because it's negative 3 in the middle. That also is nice because now you end up canceling these out, and you have a over a minus 6, which to me says the excluded value is 6. A cannot equal 6. And since, oh, I forgot one. The other one is, since when you factor this out, you have a plus 3 on the bottom, a can also not equal negative 3. And that's because of this. I simplified it, but still, if you tried in the original equation, right here you would have 3 times negative 3 is 9, and then 9. The middle part would be 9. Because negative 3 times negative 3 is still 9. So you have 9 plus 9 is 18 minus 18. It still gives you 0. So that would be why both of them are like that. And there you go. Now here's number 35. And in this section, it even says find the zeros of each function. That does not mean excluded values. Well, this should be a 3 actually. Let's try that. There we go. What that means is set it equal to 0. So just add that. Okay. Well, I think first thing on top I'm going to factor out an x, because that'll give me x squared minus 4x minus 12 over x plus 2. Still equal to 0. Alright, now let's see. 6 and 2 it looks like for the top part here. 6 and 2, and it looks like the 6 needs to be smaller. So I'm going to have x times x minus 6 and x plus 2. Well, it's getting kind of tight there. Over x plus 2. Okay, this cancels, so I should have x times x minus 6 equals 0. I'm pretty sure then that means that x equals 0, because that's what this tells me. If I want this to be 0, this could be 0, and then 0 times whatever equals 0. The other one could be x equals 6. Because again, remember when we did this before, you have to set both of them equal to 0 and solve. X equals 0, x minus 6 equals 0, move the 6, x equals 6. That's how you find the zeros, different than excluded values. And here's number 39 down at the bottom, 8x to the 5th minus 10xy squared over 2xy cubed. Then it says simplify and then state the excluded values. Alright, so if I look at the top, looks like I can take a 2x out. So then that would give me 4x to the 4th minus 5y squared, I believe. And on the bottom, 2x. Now, if I think of this as 2x times y cubed, I can then cancel these out. So at this point now, it is simplified, because there's nothing else I can do here. I can't magically subtract those. There's nothing in common. The y cubed on the bottom. That is it. Now, I have to figure out the excluded values. If you go back and you look, y cubed, well, y cannot equal 0. Alright? And since I started the whole thing with an x up there, x also cannot be 0. So there you go. That is the final thing. What you are going to is 694 to 695, numbers 12 to 42 even. There you go. That's it. 42 will be the hardest. See what you can do on that, and we'll go from there.